Oh, welcome back to Sunday Science, everybody. Glad to have you all with us today. So today, well, let's say it as simply as possible. SciStrike has sparked an interest in me in getting back into some electrical experiments that are, well, they can be a little dangerous. They are extraordinarily fun. Uh, for anyone that has been watching for a while, I'm sure you've already seen that SciStrike has put together a very awesome Tesla coil. And with that in mind, I got the spark ignited in me to go ahead and start doing some builds such as that, as opposed to focusing so much on astronomy, because it is that time of year where it is very cold outside, and even though it's some of the best viewing, it's really hard to just sit outside in the cold and wait for things to come up into the celestial. Yeah, it's cold. So, with that in mind, with SciStrike having done the Van de Graaff and the Tesla coil that he's working on, I really didn't feel like I had a choice but to start doing some experimentation, some builds, not really experiments, they're already known exactly how it is they work, but building some awesome fun out in the front yard and making a Jacob's ladder. And just so everyone, if anyone isn't already aware, Jacob's ladders are a tremendous amount of fun. You've probably seen them all in Frankenstein movies, and the mad scientist always seems to have one in the corner. However, they're a little dangerous to build. You can run into some issues that you might not have anticipated when you're making one. The one that I made, super simple. Its primary components actually come from a microwave oven. That's where you're going to get a decent coil push. It's not quite strong enough to self-arc, but it's still a lot of fun to sit down and build one, and it's also real easy to start the whole darn contraption on fire. I'm not gonna lie, they're really easy to. It's really easy to start a transformer on fire if you negate circuit breakers and make the energy company mad because you pulled a direct line out of your panel. I probably shouldn't have done that, but you know, live and learn. Well, with that being said, I suppose you want to go ahead and play one of those as long as it's not the one we were talking about.
Right.
Any one of those videos will probably work for a quick demonstration.
All right. Here comes one.
So obviously, with the amount of power that I do have supplied in this particular setup, and this looks like before the fire because there's no ash covering the seat and no ash covering the board.
And there it goes.
Yep, and I blew the circuit breaker, so definitely before the fire. But you know, the power necessary for a self-arcing Jacob's ladder is, well, I shouldn't say power, but the amount of current necessary for a self-sustaining arc Jacob's ladder is tremendously high and can be extremely dangerous to work with. If you've never built an apparatus such as this, I do not recommend starting off on that particular end. While it is a lot of fun, you are talking about extremely high current coming out of a microwave transformer, and well, it's not simple science, and it is definitely dangerous. With this particular setup that I had going on, obviously you saw the screw sticking out of a paint stir so that I could induce an arc, because Jacob's ladders aren't just going to run themselves without a high enough current. So if you do an experiment like this, make sure that you are sitting down and taking all of the proper precautions to avoid getting yourself in trouble in any way, because it can happen very quick.
I can vouch for that one. In the distant past, I ended up 12 feet from where I started.
Yeah, electricity is a very, very powerful thing. I remember once upon a time, I think I was in maybe the 2nd or 3rd grade or so, my awesome geologist of a dad decided he was going to take me out of school to go and take me on a trip where he was mapping out a portion of the Central Rockies with a colleague of his. And we got into a bit of a storm, stuck out in the middle of a boulder field, and I remember seeing my dad's friend bolt and my dad bolt, and I was not large enough at the time to keep up with them, and well, there was a bright flash and I was not in the boulder field anymore. I was pinned against a tree. Oh. Felt like I was about to die.
Yeah, that's the worst part. After receiving a shock of any sort is the, okay, what just happened? Okay, let's see. Is my heart still going? Yes.
Yeah,
okay.
it's terrifying. It's absolutely terrifying, and I wasn't directly struck by lightning by any means, but it did strike the boulder that I was leaping off of, and the rain had made me wet enough to get a nice little arc into my foot and make my jump probably the longest jump I've ever made in my life. Never stopped me from going and climbing more mountains, though, and it shouldn't deter anyone from going and enjoying the great outdoors. But sitting down with a contraption like this, you have much more anticipated electrical current, and yeah, don't touch your ground wires. It's just not smart. It's a lot of fun. They can be tremendously fun to create and build and teach people about electricity. Just make sure that everything has been discharged properly before manipulating whatever it is that you're using for your wires, because in this particular instance, I was using number 4 ground wire, so it's just number 4 bare copper, good sturdy, what's number 4 is around 0.2 inches, 0.18, I think, inches in diameter, so you can get an awful lot of current running through that thing before you're going to have any issues with it. And if you don't make sure everything's discharged before fiddling with it, it could be very dangerous. So just a side note, be careful. Electricity is fun, but it's also dangerous.
Indeed. Do you want here? Why don't we show another one of it in operation? Again, not the one.
Indeed, in operate, not the one we were talking about, but possibly the one that shows just how high of temperatures plasma can reach when you're dealing with the Jacob's ladder.
Ah, I know exactly which one you mean.
I figured you would. So, yeah, it's incredible. Yeah, you get the idea. There's a lot of energy being transferred between those two little wires, and best to just play it safe. If you do build the Jacob's ladder, I suggest going the route with the nail in some sort of insulated apparatus. Even once you've unplugged it, there can still be an errant charge in the transformer, and you're going to want to short circuit that. And yeah, you can obviously see the char marks from a possible video that is going to wind up being shown at some point.
That we might be seeing in the somewhat near future. Yeah, I admire your bravery for using a microwave transformer, because, like, uber high voltage is cool as long as you have almost nil in the way of current. Unfortunately, your microwave transformer is designed to provide both. It's
Oh yeah, there's a lot of. When you sit down and if you actually frame by frame go through some of these videos of that arc, you can see the bright green flame of copper itself actually burning off of the copper wires.
Yeah, that's the higher current rating. That'll do that. That's what I'm partial to TV flyback transformers and automotive spark coils, because you can get the voltage out of them at very low currents. But anyway.
Yes, microwave transformers are easy to acquire, but they are incredibly dangerous to work with. As Psystrike mentioned, they do output a tremendous amount of current.
Funny how I'd know that. Another thing you might want to stay away from is old oil furnace ignition coils, which can also have about 6,000 volts, but kind of high current as well. And that would be what I was referring to earlier. And you said the magic words with the "don't touch your ground wires," because this was at about the age of 14. I was having a great time with the thing. I decided it would look cooler in the dark, so I decided to reach over and flip off the light switch with a nice chromed faceplate. So yeah, that didn't go so well.
Oof. Yeah, my retinas are still recovering from daytime arcs. I wanted to film it at night, but I don't think that's actually going to wind up happening with this one. It's just too bright. Too much energy.
Indeed.
So obviously Jacob's Ladders are a tremendous amount of fun. They're always in horror movies. I don't know why, but ever since the first Frankenstein movie, a Jacob's Ladder has to be part of a Mad Scientist collection, and so does a build that you've been working on, and I'm sure everybody here would love to see the progress that you've been making with that Tesla coil there, Sai.
Oh, I could be, as if I haven't been chewing everybody's ear off with descriptions of it for the last week. I would be happy to do that.
Well, that doesn't mean everybody has had their ear chewed off with yet.
Indeed. It's getting so Andy just hangs up on me now when I got it. So every detail he now knows about the coil. So, did you have an additional video that we may have talked about, or are you saving that for later?
Oh, why don't we just go ahead and get it out of the way? There is a pesky thing that can happen with Transformers when you decide to... Well, obviously you heard me say, I kept tripping the breaker, I tripped the breaker, I tripped the breaker. Well, those breakers are in place for a very good reason. And, well, this video sums it up pretty quick as to why you shouldn't go and breach your box and make the energy company angry by pulling direct off of the line without a breaker involved.
So, on that note, shall I proceed?
Sure.
All right, here we go.
And too much voltage. Whoops.
Guess we're not going to be microwaving anything for dinner.
Nope. The microwave is, the microwave number 1, its transformer is completely shot. I actually melted the primary coil into a solid mass of copper, so there's effectively no windings left. The secondary coil is pretty darn close. It's charred and starting to show signs of actually carbonizing, which I wasn't aware you could do that, but yep, I completely melted a transformer on my patio, and I can't sit in that chair anymore. That transformer is completely dead. It's one giant ball of goo and ick, and that was a big mistake. Don't ever circumvent a circuit breaker just for the sake of science. That was a stupid idea. I had a funny feeling it would happen, but I had to do it just to see.
Okay, I'll be right back. I gotta remove some wires from the panel. I'll be back with you. Anyway, so yeah, and we were communicating earlier. I made the old radio man's joke. I know why the circuit is no longer working. It's he allowed the smoke to escape. Smoke is what makes everything electronic run. And if you allow the smoke to escape, invariably the circuit fails to run. So that was... All right, look, to me it's hilarious, okay? this is what
I thought it was pretty darn funny, actually.
Anyway, all right, so, yeah, I wouldn't... if you want to have fun, I would not toss the... Did you say the primary was scorched, or you're sure the primary is... I mean, the secondary is what I'm talking about. The secondary is scorched, or the secondary is compromised? It's like... Because if it's good, if you cut off the original primary and put much fewer wines, you could fit it with 12 volts and get a couple of kilovolts out of it. That might be...
I have to knock some of the carbon buildup off of it. The primary is definitely ruined. It's, like I say, it's fused. It essentially welded itself into one solid mass, and the secondary is covered with so much carbon residue, I can't tell the level of damage yet. Instead of tinkering with it, I just went and ran over to the thrift shop and bought another microwave and pulled another transformer out of it, because,
I'm guilty
I
of that
do
as
that
well.
kind of thing.
I'm guilty of that as well. I need a part. Nothing's open. Walmart's open. What do they have? Ceiling
Right, I
fan.
mean, a $5 thrift store microwave gives you a pretty awesome transformer.
Yeah, and if you need a lot of fine gauge wire to wind coils and such, anything with a motor or anything with a transformer will do. But I always feel guilty when I take a brand new item and bash it to pieces to get to something like that. But
hey, sometimes you just need parts, not a product.
Absolutely, and if that's your only option, there you go. That's what you got. But all right.
Exactly.
I have noticed, in it, you saw the link already, that there's some I guess it's a Chinese outfit that's making flyback transformers for next to nothing, which is very useful in this kind of thing. One, because you feed it with 12 volts, so you can throw a little isolation transformer in between, and two, the current is not quite what would kill you. It's about they're anywhere like 30 to 40,000 volts out, but the current is extremely low. So it's just skin effect. You'll get a shock and you'll be annoyed, but it all basically just travels over the surface of your skin. Oh, and hurts. I should mention that.
Oh yeah, that's got to be hot and painful.
Yeah.
That's part of the reason I was looking at the one that I shared with you earlier. I think even all the way at 15 kilovolts, it only puts out 30 microamps. So
that's nice, and that'll
that's survivable, and
safer than microwave, and much safer than the old oil furnace transformers, which you can't kill them with a mallet. You won't have to worry about damaging the primaries. You might accidentally lose a finger or two. That's why I do not recommend their use for anything but igniting oil in an oil furnace. Let that particular one do what it was intended. Anything else, bend to our will.
Absolutely.
So, yeah. You're gonna work on not letting the smoke escape from future projects, I hear.
I am. I'm going to build a containment box to make sure that all of that burned electrical smoke stays in the apparatus so it keeps working. I will have to put an acrylic front on it, though, so that you can at least see the mad science happening.
You wouldn't want to miss the show.
Oh, of course not.
Indeed. So, well, I'm rather honored that I inspired you to start. I heard what you did there. I sparked your interest. That was very good. Uh, I'm actually rather honored that I inspired you to move into the electrical slash electronic area of science. I know you had quite a bit going on in several other areas. So,
Well, I've always been very intrigued by chemistry and physics and astronomy. I mean, anyone watching the show obviously knows those are my primary interests when it comes to science. But I've also been building computers since I was very young, and I work programming machine tools for a living. Electronics are an absolute necessity this day and age, so every now and then you do have to go back to the roots and just take the time to sit down and make sure that you're doing it safely, but mess around with electronics. Our society as we know it this day and age would not exist without people having sat down and done this kind of stupid stuff. So,
indeed. And now
some,
look, primary, was that a Transformer joke? Your primary interest was that?
every now and then I try and pull science puns in.
Indeed. All right. Anyway, yeah, I feel bad for your little Transformer there. It gave its all for for your project, but
It did give its all, but maybe at least this provides me an opportunity to sit down, and it's not going to be easy, but maybe use a sledgehammer and a wedge and somehow break it apart so that I can teach some younger people why it is that cores of transformers are laminated and how it is that the windings function, because it's completely useless at this point in time, and you might as well take it apart and teach someone that has a brain wanting to learn something new.
indeed. Well, and your method of disassembling the Transformer, I can tell you've had to do it before.
It's not easy.
Yeah, well, it's
not necessarily looking forward to it, but
well, it would be
there is a lot
nice
to learn about why it is that the core of a transformer is laminated, how the winding structure works, and what it is that's actually taking place there. I don't want to get too deep into any of that right now, just because a lot of it's really boring and
eddy currents. Sorry, what?
Yeah. Eddies are annoying.
Yes. A lot of and it's and with all the electronics we have now, we think of basic transformers as extremely low tech devices. They're not. There's a lot of calculation that has to go into making one that functions. And you just think of the primary taking wall current into it. It has to have enough inductance. It's not just number of loops on one side, number of loops on the other side. Then you get that will tell you how much of a step up it is, or opposite, how much of a step down it is. There's more than that. If the inductance of the primary is not such that it basically acts like a choke to wall current at 60 hertz, it'll glow red and vaporize. So I mean, there's a lot of things that we don't even think about for the most part. Okay, I need a 12 volt power supply. Okay, I'll use this transformer, and that's considered the lowest tech part of your project. But
right.
even that, there's quite a bit of science too.
Oh, absolutely. Transformers are absolutely amazing creations, and I am so thankful that somebody sat down and took the time to go, what's going to happen if I do this?
And who was one of the big ones in that area? Oh yeah, Transformers. That if we had listened to Mr. Edison would be utterly useless because we'd be pushing direct current to all the houses, and you can't really do anything with that.
Yeah, what good would that do? We'd have a power station every mile and a half, and a whole lot of. I mean, sure, it'd be great for industrializing everything, but it would just mean there's a power station every mile.
Absolutely, and think of your guitar amp. No more AC hum.
Nope. Oh.
Yeah, but.
Oh God, who is the guy that spoke through his guitar basically with the wah-wah pedal? Yeah, that wouldn't exist.
Wait a minute, who was that?
Why? I don't know why I'm drawing a blank on this. He's an incredibly famous artist.
Wait a minute. Yeah, the name escapes me. Is that the same guy who did? No. You know what? I don't remember. Don't remember.
Yeah. Anywho,
anybody's wondering about that, we'll get back to you.
Indeed.
Anyway, yeah. So
aside from me burning down a transformer and getting, oh, that's right, I haven't actually gotten to that portion yet. So funny thing, my neighbor that seems to be very unfriendly when it comes to me doing science experiments in my front yard. I guess this is why I originally went with the term backyard science, because obviously I need to move behind a fence, otherwise I'm going to keep getting the cops called on me. Decided that my Jacob's Ladder was means to call the sheriff. I'm not entirely sure why, and I really don't care why, but at this point in time, there is the almost weekly drive-by by my neighborhood sheriff. I do live in an unincorporated portion of the county, so I don't have city or state. It's always county, so it's the sheriff. And yeah, sure enough, between this nice little transformer burned down and then a rebuild with a new transformer, sorry anybody shopping at Goodwill that actually needed a microwave, I beat you to it. But
well, that's okay. Tell them to bring their food over. That transformer's probably still hot.
Oh yeah, I haven't touched it. That was yesterday. I still haven't touched it. I don't want to know.
So when one of the old Frankenstein movies comes on TV, do you think your neighbor calls out the National Guard? I mean, what exactly was the fear here? What?
He just doesn't like me, so anytime that I'm doing something that he has an excuse for, I don't know, I guess I'm the 40-year-old Dennis the Menace for him. Not really sure.
Well, I guess things never get boring over there.
Oh no, it's always exciting. Anywho, I do believe that there was a Tesla coil that you've been working on that I think a lot of people would be interested in seeing.
Funny you'd mention that. I just happen to have some stuff ready to demonstrate.
Very nice.
It's almost as if it's like you knew. All right, here we go.
Oh, you know, mad scientist to mad scientist.
Cut the volume a bit. Barking gets to be a little deafening. Anyway, here we go. Here's what I've been fiddling with so far. Here's the little fella. There's the spark gap. I'll be going over what the hell everything does in a second.
I still can't believe you wound that thing by hand.
Hey, well, there was nothing on TV. Yeah, there was lighting up one of those neon bulbs. This was early on when I wasn't sure how my homemade capacitor was going to behave, so I was pulsing it instead of just letting it run. And It lights up one of those little household CFLs at a distance.
Okay, I do have to ask, the homemade capacitor.
Yes.
I saw the pictures of the build. Can you explain that one a little bit more in depth? Because that is it seems so simple by the way that it looks, but I know that there's a lot more happening than what meets the eye.
Oh, sure. Actually, a little later on here we have a picture of it, and then I'll do exactly that.
Awesome.
All right. So this is yeah. So far we've had it lighting up a neon bulb held in the field, and and one of the CFLs being illuminated by being held near in the field. And what else did I? Yep, more of that.
I do have to wonder, how in the world were you not picking up any sort of feedback loop with your phone or camera recording that?
Well, very interesting that you would ask that as well, because a lot of people describe a Tesla coil as big transformer. It's not. There's more to it than that. Oh, there it is, making a little corona discharge.
Nice.
Now, it's here's the circuit for the thing. It's frightfully simple. A Tesla coil, besides being a transformer, is also, and I don't know why nobody seems to talk about this when they talk about Tesla coils. It's a radio transmitter. That's what it is. That's why it makes the corona discharges. That's why it lights up, light bulbs like that at a distance, without any visible sparks going to them or anything like that. Whereas with the Van de Graaff, you would have to hold it close enough for an actual discharge of voltage. What's lighting these, what lit up those two things, was being in an AC field, just like it would get if it was screwed into a wall socket. So, and that is where you get the ridiculously high voltage potential off a Tesla coil. Is you're not just going with the windings ratio to give you the higher voltages. I know you're aware, Andy, the higher you go in frequency, the weirder electricity acts. And when you get into RF, radio frequency type stuff, along a conductor, or a transmission line, or an antenna, there are points where, in a perfect conductor, the current would be infinite and the voltage would be zero. They run out of phase with each other. And then a little farther down the transmission line, it's the opposite, where the voltage would be theoretically infinite and the current would be zero. And it's that kind of behavior that gives you the ridiculously high voltages with a Tesla coil. Not just a windings thing. So, yeah. All right, we should be getting to the capacitor any time now.
Yeah, the homemade capacitor, I gotta say, that was...
Here we go. This was early on.
Yeah, I've been wanting to ask you about this build all week, and I finally get to.
Okay, it's not going to be nearly as exciting as you may have hoped, and I'll apologize.
Well, the errant capacitance doesn't need to be super exciting. It just needs to be well understood, and this is proof of how well understood it is, because it's not difficult.
Indeed. A capacitor, for anyone unfamiliar with it, it's basically a device for storing a charge. Yeah, it's sort of like a battery, but not really, because this standard storage battery of any sort, wet cell, dry cell, all of them, are restricted in how quickly they can release the stored charge. Capacitors are not. They'll release 100% of their charge almost instantly, which is where in this circuit, I mentioned I use flyback transformer because it has a very low current. In this circuit, I decided, since it's necessary for a Tesla coil, because it needs high current, I would negate that safety factor by using you have to charge a capacitor and have it discharge through the primary. So all safety of low current, high voltage is gone. Once the capacitor is charged, you are high voltage, high current, and instant discharge. That's why whenever you're fussing with a capacitor, even if it's been sitting on the shelf for months, do what you said earlier. The safety tip you gave, short it. Short it with a screwdriver or whatever you have to before you touch the leads. Because they can store
I have
charge for a
from
long time.
Maxwell Electronics, I have a D-cell sized flash capacitor that's been sitting on my end table now for about a month, and I still haven't checked to see if it's discharged.
I'll toss it to someone. That's what we used to do. No, don't. Do not.
I did that in school. It was
not
it was
to be
fun
done.
the first time, not fun the second, third, fourth, or fifth time.
Yeah, well, once the kid catches you, then it's no fun anymore. But anyway, you asked about the capacitor and how it was. Now, it was a very simple build. A capacitor stores a charge basically by having two plates with an insulator of some sort between them. There are a bunch of different kinds of capacitors. They all basically do the same thing. When you apply a charge to two plates next to each other with an insulator in between, you have a negative on one side and a positive on the other. The charges are that when you disconnect it, once it's charged, those are held in place by the attraction of the positives on one side and the negatives on the other side of the insulator. So they just stay there until they find a nice low resistance path to meet up again, which hopefully, as we just talked about, is not hand. In this case, it was built with highly sciencey, technical, hard to get stuff. This was basically a bunch of squares of glass from dollar store picture frames. That's the insulator in between the plates, and the plates are aluminum foil, and it's layered. Alternating. The bottommost plate goes off to one side, the next one up goes to the other side, so you have alternating a positive and negative, so that when the entire thing charges, it stays. That's basically how this was constructed. It was one slab of glass, one layer of aluminum, and a whole bunch of Elmer's rubber cement. Which happens when it cures, it happens to make an excellent insulator. If anyone is thinking of building a capacitor of this sort, you do have to make sure that it is very well insulated. You have to coat the entire surface, both surfaces, the glass you're putting your aluminum on and the one that you're putting on top of it, with the rubber cement, because if at these voltages, if you do not have a complete seal all the way around, not seal, it just has to be a complete coverage. The coronal discharge from the ends, all the way around the aluminum, will creep out that layer of glass and arc to the conductor of the next plate, and you'll have a capacitor that basically discharges itself and is useless, and will heat up and cause bad things, and as we talked about before, allow the smoke to escape. So,
well, yeah, you never want the smoke to escape in electrical systems.
Indeed.
So I have to, aside from the joking, I do have to ask, how many layers happen to be in this particular homemade capacitor?
This is the original one. Both the original capacitor seen here and the original primary coil seen here had to be replaced. Remember what I was saying about make sure you have the insulating material all the way around, which in this case was rubber cement?
Mm-hmm.
Well, apparently there was a just about the size of a pinhole air gap in between one of them. So this one ended up arcing out. So I have a new one I had to make another one. Can you believe it? I had to spend another $6. Jeez. Anyway, and high voltage capacitors are ridiculously priced. So making your own can be a good idea.
And yet somehow the flat tards think it still takes billion worth of scientific equipment to perform a test.
Indeed. But yeah, the one that's in it now has.
I was at the thrift store. You were at the dollar store. I'm pretty sure. Yeah.
Oh, you can find science anywhere. As a matter of fact, if you have a Harbor Freight in the area, ooh, that's the place to go.
Oh, Harbor Freight is good for parts.
Anyway, I guess I should have answered your question though, huh? 8.
8. Okay, 8 layers of aluminum foil. So you have 4 on the positive, 4 on the negative.
Exactly. 4 pairs, and since they're layered, both sides are active except for the top aluminum and the bottom one. So it's a fairly effective way. And in a circuit like this, a good way to do it is to make it less capacitance than you think you need. Because you can always throw on another slab while it's not while it's running, obviously, but without disassembling anything. We would, like in this picture, we would coat the top with rubber cement, throw some aluminum on, another layer of glass, another layer of aluminum. There you have 2 new plates. So you can bring it up in capacitance as needed. So yeah, that was fun. And and try not to leave any air bubbles because then they can explode.
Sometimes there are fires when you do electrical experiments.
Indeed. And again,
especially building your own capacitor.
Yeah, safety precautions, wear eye protection, regular glasses. Well, I have regular glasses. No. Get the funky looking ones that kind of seal off your head and make you look like that robot from that cartoon. So anyway, yeah. All right, let's move on here. All right, that is the spark gap. It was an extremely low-tech way to generate a pulse. What happens in this particular circuit is the high voltage power supply charges up the capacitor. When the capacitor is not charged, it's a low resistance path, so very little of the current is actually getting to that primary coil. When the capacitor has a sufficient charge to make an arc, everything in the capacitor plus what's coming out of the flyback transformer gets blasted through the primary coil. That's a high amount of current, and that's why the primary coil is made of 1/4-inch copper tubing in this picture. Once it starts, this produces, theoretically, if your capacitor and your coil are matched, you have a resonant circuit, and it oscillates. And that's what makes that radio frequency that we were talking about earlier. Anyway, all right, let's see what else we got here. Oh yeah, and by the way, I was, you know how you got to wear a welding mask when you're welding?
Oh yeah.
Yeah, this is, I probably should have had a welding mask on, but my eyes were shielded by the phone.
Yeah, I know the feeling. I'm still seeing a Jacob's Ladder arc every time I close my eyes.
That's another reason for high voltage and low current. You'll have a nice arc, but not that blinding arc. In this case,
the blinding arc is fun though, because I do get to actually burn off the copper, so the plasma is green, and it's, well, from previous episodes of Sunday Science, obviously we know that copper sulfate has a tendency to burn in the green spectrum, and a Jacob's Ladder, if you have way too much current running through it, will do the same.
Indeed. All right, there was, and you see I got those little shelf things to make it look a little decorative. Eventually, there's going to be smoked glass in front of and behind this, and I'll have a little air force through it to keep it cool. But, obviously it's not finished yet. Let's see, what else we got? Did I make that? Okay, yeah. The wiring was point-to-point underneath. The base, the fabulous base, is a tray of some sort, sourced from that science supply house. What's it called? The big one. Oh yeah, Walmart. All right. How long did I keep it on this picture? Come on, move. There we go. Here's the primary coil, and that was hand wound. The top insulator has a lot.
And
if I remember
from moving that, you said that was 24 gauge wire.
No, 28.
28.
28. Yeah,
that was close.
Not quite thin enough to be annoying. Up in the 30 gauge, that's when things start getting annoying to where every little kink ruins your project. But
indeed,
yeah, and the top insulator there, which is designed to prevent arcing from the top electrode back to the coil because it can damage it. Notice it has that sort of scalloped appearance. You want as much surface area as possible to help it, from arcs going around the outside of it. Yeah, those are those things you put under the feet of the piano so it doesn't dig into your rug. That's what those are.
Good use of stuff lying around the house.
Well, that's any of the projects I try and do. I try to make it so if someone wants to make them. Oh yeah, here's a better view of the capacitor. When it was, it had just been made. It's all glued up, and I have it clamped to so that the rubber cement can cure. Yeah, that's that. Easy to make.
That's actually really awesome that you excuse me, had to belch.
Not a problem.
For anyone that has sat down and taken apart any sort of electronic device, you've always seen capacitors and resistors and transistors inside of whatever it is that you took apart. But when you're sitting down and you're actually looking at those because you just, took apart a radio, and it's a broken radio, it doesn't work, nobody cares about it anymore, and you look at the PCB on it, and you see all those little nubs sticking off of it, and you're going, what is this one? What is that one? Why is this one shaped this way and that one shaped that way? It's so much fun to sit down and be able to dissect something like that and go, okay, well, now I know this is a capacitor, and its purpose, because I can map out where it is that it lies in the entire circuit. It serves this particular purpose. And this one is a transistor, and it serves this particular purpose. And this one's a resistor, so it's making sure that there isn't too much current going to this place. And electronics are really a tremendous amount of fun. I would actually like making this potentially a 2-part episode and seeing if some other individuals that I tried inviting once, but maybe I'll have to invite twice to join in, because I know their knowledge of certain things is above mine. I'm more mechanical than I am electric, but it's really fun to be able to sit down and dissect something and look at the components, and instead of just going, wow, this is a weird looking green board with solder on it, and actually looking at everything that's involved in the series and going, okay, this capacitor is doing this job for this particular purpose, and this resistor, it is doing this job for this particular purpose. It's a lot of fun. Electronics are extremely fun, and with them being such a vital part of our day-to-day lives, I hope that people are enthusiastic enough to go and learn these things, because it's how every day works for us. It's how your cell phone works, how your computer works. It's just fun.
Indeed, and more than just for understanding, it can also come in handy if one of your favorite devices ceases to function. There's a much greater chance you can find out why if you understand what some of the components inside actually do.
Absolutely
comes in handy. But yeah, this was a fun one. It's still operating underpowered at the moment, not because of the power supply or anything like that, but because with only 4 pairs in the capacitor, it's not throwing that much current through the primary. Secondly, it's not at resonance yet. I mentioned that it's the thing is basically a Tesla coil is basically a large radio transmitter, where you get the most throughput is where you have both the primary and the secondary resonant to the same frequency, which is determined by a combination of the capacitor and the coil. It's called an LC circuit. C for capacitance and L, quite obviously, for inductance. Makes sense. Anyway, the only reason that it's running at low power is because before I made it capable of full power transfer and having the kind of current necessary to make those 3-foot long arcs, I just kind of wanted to make sure it wasn't going to burst into flame. So we're all good up to that point, and by my math, I need about somewhere between 6 and 8 more layers to bring the thing to resonance, to where I should probably say why that matters. Resonance is where each pulse from the spark gap basically kicks the coil at just the right time, that there's like an echo coming from the last pulse. So each one is additive. Each time you pulse voltage into it, it's additive to the previous one. That's basically, when it's resonant, that's what it does. That's where that's how you get the maximum power transfer between the two coils, and that's where you get the way cool mega sparks. So mega sparks coming, and hopefully fire.
Very awesome.
Alrighty, there you go. That's that. And so that's the fun I've been having. Oh, look at that. Squirrel says I'm quiet. Am I too quiet? No one's ever accused me of quiet before. That just
it's not that you're quiet, it's that I'm loud.
Okay, well, that works.
I've been told my entire life that I have a voice that carries, and I should use it infrequently because of the fact that it is a voice that carries. And yeah, no, I'd rather sit down and use a carrying voice to hopefully get individuals enthusiastic about homemade science experiments and all of the things that are so much fun that you can do very easily. I mean, aside from sitting down and winding coils, yes, that's going to take a little while, and it's
very boring.
Yep. The results, once you actually get through the monotony, are amazing. And it's an amazing amount of fun to sit down and do. So I would definitely suggest to anyone out there, sit down with a good electrical engineering book. Maybe not actually electrical engineering, but just basic electrical computer science or something of that nature. Give it a try. Make a small Tesla coil. Make a small Jacob's ladder. I mean, you can actually make a Jacob's ladder off of a USB. I mean, 5 volts. It doesn't have to be extremely wildly large amounts of current. It doesn't need to be high voltages. You can make a Jacob's ladder and off of very, very small voltages, very small current draws that aren't going to do any damage. But just make sure you're following safe practices with electronics as you go about that, because it can be dangerous. Even at 5 volts, if you have too much current, if you have too many amps, it can be dangerous. So it's something that everyone can do that is very fun, but you should always practice every safety precaution you can imagine when dealing with electronics.
Agreed. And Nathaniel, yes, actually, I was going to kind of PDF up once I'm absolutely sure everything's as it ought to be, and I've run the thing at full power. I was going to make a PDF as to how I did it, at least, and just make that downloadable. but just because I know I've done it, start to finish, it's going to work. There's how-tos for Tesla coils all over the internet, but rather than just linking, if I haven't followed their procedure exactly, I can't say this will work. So I plan on making a PDF, and it will be posted. I'll probably when it's done, I'll probably throw a link to it in the description of this video as well. But that will be available. Will that do? No.
Hopefully.
Indeed. Just because, that's understandable, right? I wouldn't want someone to go through a project that making a Tesla coil takes a while.
And it is a very detailed instrument. It absolutely.
Yeah, and there's wind the coil, spray it with lacquer, so because you can't just leave the wires to wiggle at these frequencies. That'll screw everything up if they move while the thing's in operation.
Oh, gosh, right?
It changes the frequency of resonance, and anyway. So that takes time. You got to wait for stuff. You got to wind the coil. You have to you have to either make, buy, order capacitors. There's a fair amount of work involved, and I would just like to make sure that if someone's going to go through that much work, I'd like to make sure it's something that's going to function when they're done with it, because that can be very depressing when you spend a lot of time with something and it
Indeed.
It just does nothing when you're done.
Oh, SideStrike, I do have to say it appears to be 5:57, and I believe you had a engagement that is far more awesome than sitting around and talking science.
Well, there are very few things that are more awesome than talking science, but yes, I do have to be out of here. I hope.
I didn't want to keep you too long. I do really appreciate you hosting Science Sunday, and like I say, I just don't want to keep you too long because there are certain things that are they're just more important.
Oh, most kind of you to remember. I was not actually watching the clock. I'm glad you brought that up because, as you may have noticed in the past, once I get talking about a project, it can go on for quite a while. So
likewise.
Good that you pointed that out. All right, back to you, Andy.
Okay, well, I suppose this is it for Science Sunday on this beautiful day, 17th December, 2017. And I hope to see everybody next weekend. If you have any projects or ideas that you're interested in sharing, please feel free to leave them in the comments leave them in the comments, and I guarantee I will get to them, and maybe next week's episode can be a second round of homemade scientific fun.
Sounds good.
That's about all I have.
All right. Well, very good. On that note, perhaps we should say goodnight, all.
Indeed. Have a great weekend. Remainder of the weekend, everyone.
Indeed. See you next time.